The second activity on circles is proving that central angle is a double the inscribed angle. How to do this activity? For this activity, we want a cutout of this kind where there is a circle and 2 points are marked on the circle, A and B. When we connect these 2 points on the circle to center of the circle, we get central angle. When these 2 points are connected to any point on the remaining part of the circle, we get the inscribed angle. Like C is a point on the circle. When A and B are connected to C, we get this angle. This angle is called inscribed angle. How many central angles are possible and how many inscribed angles are possible? See, I'm placing the rubber band between these 2 points. So in a way, if I hold this like this, connecting A and B, we get a chord. Chord of a circle divides a circle into 2 segments. This one is called minor segment and the other one is called major segment. Fine. Now when these 2 points are connected to center of the circle, we get central angle. So there is only one central angle, but how many inscribed angle? When these 2 points are connected to any point in the major arc of the circle, we get inscribed angle. So this is inscribed, this is also inscribed, inscribed. So we have infinite number of points in the major arc, and all of them, when we connect to the 2 points A and B, we get multiple infinite number of inscribed angles. Inscribed angle is also formed when we connect point A and B to a point in the minor arc. So minor arc, this is inscribed angle, this is also inscribed angle. So here, these 2 points, when we connect to infinite number of points in this, then also we get inscribed angle. So this central angle will be connected to inscribed angle in this zone, and reflex of central angle will be connected to this zone inscribed angles. That's the first point. Next, this activity is to prove that central angle is always a double inscribed angle. Keep this in mind. This has connection with this angle, means angles in this zone. This angle has connection with angles in this zone. To prove this, I have taken 2 cutouts which measures same as the central angle AOB. Now, what about these 2 angles? Are they equal in measure? See, they have perfectly superimposed, so they are equal in measure. So each of them is a half of the total angle. One of the half pieces I slide and place it here, and you see what happens. Half of AOB is the same as ACB. That means inscribed angle is actually half of the central angle. This part also, if I slide, you see this perfectly superimposes. So central angles double is inscribed angle, and inscribed angle is the half piece of the central angle. So central angle is a double inscribed angle. Inscribed angle is half of central angle. Then is this true for all other inscribed angles? Let's check that also. So I'm holding the rubber band between these 2. Let's have one more inscribed angle, something like this I'm getting. So I get ready with, yeah. So you see the half piece at the angle AOB, central angle, is suiting here also. So it will suit everywhere in fact. So as I turn this rubber band on remaining part of the circle, we will find that this angle is suitable for all the inscribed angles. So what is the conclusion drawn out of it? The conclusion is central angle is a double inscribed angle, that's clear. This angle is a 2 times this angle. And how many this kind of angles are there in inscribed angle? There are infinitely many of them. And all those infinite inscribed angles are equal to 2 times AOB. Means all the angles that you get here, they are all, you understand? All those angles inscribed. So if I connect A and B to a point here, say D, we get the next inscribed angle. See, this inscribed angle is also half of this full angle. If I connect this point, some E, to A and B, I should take a scale in fact for doing this. Then I'm fixing this half of AOB here. See, this is perfectly superimposing. That means all the inscribed angles, angle ACD, ADB, AEB, all of them are equal to each other because all of them are half of central angle. So the final statement for this activity should be central angle is always a double the inscribed angle and inscribed angle is half of central angle.